Namaskar, my dear friends. Let us see one of the PIC microcontroller, which is PIC16F1619. This can be used in automotive applications for low pin count applications. So the exact device is PIC16F1619-IP. You can have -EP also. So that is for higher temperature range. Okay. What we will do in this particular session is we will try to understand what are the different scenarios that is available with us. Okay. So as you can see, we have we have the list of topics that we will be discussing for this particular microcontroller board design. First of all, we'll try to see what are the pin-to-pin compatible parts. Then we'll see microcontroller schematic. We have evaluation boards. We have PCB layout views. We have schematic designs. Then all other parts in the section of the schematic design. All right. So let us start one by one. As you can see, if you want to use this particular part, PIC16F1619, you can utilize 1619 and 1618 as well. Okay. Then we have PIC16F18346 and PIC16F18446. Okay. So these two devices are bit advanced ones for the application in automotive applications. All right. Now, as you can see, this is very nicely, a 20 pin PDIP package. So you can see from 1 to 10 and 11 to 20. So this is the pin package configuration. The best part of this device that I have seen is they have given a curiosity board which we have been using to program that as well. So this is the top view of the PCB layout for the evaluation board. Okay, and this is the microcontroller that I have been talking about, this one. All right. Now they have released a newer version also. So this is revision 2. In revision 4, you will see programming, microcontroller is upper side. So in the revision 2, this programming microcontroller is downside, but here it is upper side. And this is the same microcontroller board that is available. And as you can see, we have a push button, that is user push button. We have M touch pin. We have LEDs D4 to D7. So total 4 LEDs are there in this. We have potentiometer, and we have Bluetooth module footprint, and we have micro bus headers. So there are 2 headers with SPI configurations. All right. Anyway, it doesn't matter. However, our aim is to design our own schematic, which we will be seeing. But before that, we have already been seeing, little bit of programs using this particular curiosity board. So as you can see, we have LED driver or LED toggling or LED, switching on, switching off using the microcontroller board. Similar to that, we had seen the LED pattern as well, like one after the other, all the 4 LEDs were being blown up, right? So now we will go ahead with microcontroller schematic design. So before that, let me quickly give you a brief introduction about the data sheet. So in this data sheet, if you come to the home page, this is the particular data sheet of PIC16F1619, and it has 14 pin as well as 20 pin configuration, and it has lot of core features and digital peripheral features. We have memories and everything is there in this. However, it doesn't have EEPROM, so that's the reason I told you that 18446 or 18346 will be the better option for PIC16F series. Okay, so this is the reason these two devices also have been taken into account as a pin-to-pin compatible device. Okay. Now coming back to the program memories, and also you can see we have almost 8192 byte words of memories. Okay, so that is coming up around 14 KB or something. Then we have then we have pin configuration. So pin configuration 14 pin. So as you can see, we have 1615 and 1619, both are having PDIP packages. However, 1619 we are talking about right now, and that is having only 20 pin we will talk about. Okay, so in this package, other packages are also available, but we have PDIP package, we have SOIC, SSOP, all these package configurations are there to reduce the physical size of this particular board. Okay. Coming back to pin configuration, so this is 14 and 16 pin. Coming this one 20 pins. In 20 pin you have these three packages like PD package, SOIC package and SSOP package. So you can see pin to pin, like what is the different functionalities and what are the different features for associated with each of the pins. All right. So with this much information, now we will directly get into the circuit design concepts. So as you can see, I am opening the circuits. So very first thing what I have done is in the ORCAD schematic. So you can utilize ORCAD for constructing this particular circuit. So ORCAD capture is one of the best software that we have in this particular design. So as you can see, we have PIC16F 1619 IP, and the pins are as it is made from 1 to 10 and 11 to 20. Okay. Now we have VDD pin, which is my power supply pin, and we have VSS pin, which is the ground pin. We have one MCLR pin, which is the reset pin. So reset pin, you can see we have here reset button, MCLR going to get reset. So once you press the switch, you have reset. So beauty of this particular schematic that we have designed is we have taken the reference of evaluation board, as well as we have tried introducing our own concepts. Okay, and it is made very simple. Little bit more advancement is like we have introduced some of the like temperature sensors and other sections as well, like audio buzzer and all. So that is another part. So let us start one by one. Like how do we understand how to make this particular circuit little easier. All right, so what we can do is, first of all, we have a programming connector. So in programming connector, we have, like first pin is MCLR pin, that is reset pin, then power supply, then ground, and then we have ICSP data pin and ICSP clock pin. Okay. So this is the ICSP data and ICSP clock. Since it is a very low pin count, so what I am doing is, after programming, I can use the same pin as doing the some other work, some other IO work. Okay, so it can be used for DAC out, or it can be used for simple IO functionalities. Okay, then I have given options for like SPI. So SPI select line, SPI data line, data output, SPI data input is here. Okay, and SPI clock line is there. So there's four lines are there, like SPI, like Mozi, Mizo, and SS, and this SCK lines. Okay. We have the options for I2C line also. So I2C SDA and I2C SCA line. So if you want to interface some of the temperature sensors or pressure sensors with SPI outputs, you can do that. Even ADC uh, can be interfaced with this particular microcontroller. You have UART communications, so UART RX and UART TX is also there. Okay. However, right now I have not introduced these, functionalities because it is not needed. All right, next comes up is a power indication. So what I have done is this 3.3 volt I have taken through a 0 ohm resistor, and it is renamed as VDD, and VDD will be used for my power supply of my microcontroller and everything. So this VDD is supplying a current to an LED. So this LED will be glowing, and this is how you will know that your power supply is there on the board. So it is power up indication that is there. Okay. Then we have user LEDs that I have given you here. So you can see we have four LEDs. Three LEDs are here. That is being driven by LED 1, 2, and 3. So user LEDs. So these are renamed with LED 1, 2, 3, and RA2, RA5, and RC5. Okay. So these three lines have been actually taken from the evaluation board as well, so that you can like map it one to one, and it will be little bit easier. Later on they can be like removed, and these pins can be utilized for some other purposes as well. Okay, so there is no use of utilizing lot of LEDs. So for your understanding purpose, I have given you these three LEDs driving by the microcontroller. Okay. Now let us say you want to drive with a little bit higher current LEDs. In that case, directly power supply can drive those LEDs using one MOSFET. So these two MOSFETs are being used to drive this LED D8 and D7. Okay, so this user LED 5 and user LED 4, this will be the IO lines that will be coming from microcontroller, and this microcontroller RA0 and RA1. This is how it is there, where it is yeah, RA0 and RA1, they will be driving these two LEDs. Okay. We have introduced one temperature sensor, which is TC1047. This is also from Microchip microcontroller. So this is coming as temp out. If you want, you can take it out from here itself, or directly I have taken it from RA4. So RA4 is going to be used to measure the uh, ADC of this particular temperature sensor. Okay, so this is onboard temperature sensor that can be utilized. However, IC has inbuilt temperature sensor that can also be monitored through software. So that is a different scenario. We have put one potentiometer of 10 kilo ohm that is being again measured by ADC, which is RC0, with one low pass filter that I have put in the middle, that is R105 and C60. So this is making an low pass filter. Okay, if you want, you can remove that, or you can put even 100 ohm, because it is not having any uh, frequency or something like that. Okay, moving to the next part, we have put one USB micro B. So USB micro B, this is the part number that is there. So if you want, you can take into account and try to understand how to connect USB connector through this particular microcontroller. Okay, so what we have done is USB N and USB P, that is negative and positive, or USB plus and minus. We have D plus and D minus. So these are the two pins that is being used. So what I have done is I have used one silicon lab USB to UART bridge. Okay, so my UART pin will be coming UART RX, UART TX from the microcontroller, and they will be converted to USB signal, and USB signal will be directly communicating through our PCs. Okay, so this is how we will be communicating our UART signal to our personal laptops or something like that. So this is very simple circuit. I have not utilized lot of other functionalities in this USB to UART bridge. It is just powered up with 3.3 volt, and it is being simply acting as a UART to USB bridge. Coming back to push buttons, so I have put two extra push buttons for the user purpose. So once you press this, so it will be reading low through user PB0 and user PB1. Similar to that, both the push buttons are there, that is being used as user push button. So you can have some different functionality for this particular push buttons. There are scenarios where you need setting the IO pin as high or low all the time. Okay, it is kind of like configuring an IO pin as a input with a high or low input. So for that purpose, what you do is you slide this one left side, it will become low, and you slide this one right side, it will become high. So this is how it will happen. So as you can see, a user deep switch 0 and user deep switch 1, that can be used for this particular deep switch functionalities, where you can configure an IO as input with high or low functionality, so that you have total 4 configurations: 0, 0, 0, 1, 1, 0, 1, 1. So based on these configurations, you will be able to make some decisions in your code. Okay. Coming back to the power supply, because power supply, without power supply nothing happens. So in that case, what I have done is, as you can see, I have a power adapter jack. So it is adapter jack kind of thing. You can input like from 5 volt to 12 volt, 2 amperes rating you can put it. Okay, so anyway, like there are 6 volt 2 ampere rating available, or 12 volt 2 ampere rating power adapters are available, so you can utilize this. Now there is a connector also that has been given, so that you can separately connect a DC power supply, and you can vary the power from 5 volt to 12 volt. That doesn't matter. But if you are giving a programmable power supply, you try to give it 5 volt input, or maybe maximum 9 volt input. Okay, so that is good enough. And I have put a fuse for the safety purpose, and this diode is actually utilized to make sure that if both the powers are connected together, then also it does not fail. Okay, so one of the power will take over based on their a higher rating. Whether let's say it is 9 volt and you have connected here 6 volt, so definitely this will be taking over. Okay, and let us say you have made it 5 volt here, 5 volt here. Let me just remove all of them. It will be little easy for you to understand. So how it works is, let us say you have connected here 6 volt and here you have put 12-volt jack. So this will be superseded by this one. Okay, so this is how it will be taking up. Now I have used two regulators. One is for 5-volt regulator, 0.5 ampere current, and one is 3.3-volt regulator, zero point 0.5 ampere current. Both are from Rome Semiconductor. They are very highly recommended, like a, LDO for automotive applications. Okay, so what I have done is, this VCC is being taken and it is going to be used as 3.3 volt. Okay, so what I have done here is, there is a one jumper that has been used which sort only when input supply connected and 5-volt power regulator and USB are not used. Okay, so when you have let us say you want to use this one and USB is not connected, then you can sort this so that you can have VCC, and this VCC will be used to convert it to 3.3. Okay, otherwise what you can do is when USB is connected, then in that case you can sort these two, and in this way V bus will be utilizing V bus will be utilized as a VCC, and this is how again it will give you 3.3 volt. Okay, otherwise you don't have to do any sorting anywhere, you just remove all of them. This VNA, once you power up this thing, okay, so this VNA will be taking this one and then it will be giving you 5 volt, and this 5 volt you can now sort these two so that you can get it VCC, and this is how it will be going to 3.3 volt. So this is the several like combinations that has been given using these two jumpers to give you 3.3 volt as output. Okay, so I think this is very clear. You have the power supplies, so basically to reduce the cost you don't have to use this, only this much is sufficient. Okay, now a very simple thing, any circuits like require some EEPROM or like some memory concept. So for that purpose I have one SPI configuration. So SPI slave select or chip select is there, then SPI SDI, that is data input and data output, and we have SPI clock. So this is the particular EEPROM IC that has been used from Microchip. One very nice audio buzzer has been used so that you can utilize this for your alarm purpose or beep purposes and all. So you give one PWM signal of 2.71 kilohertz, and this is how you will be able to drive this particular audio buzzer from CUI. So CUI devices is used as CST-931AP, and this is the diode that will be using as a freewheeling diode. If you wish to, you can utilize like some other MOSFET here instead of using a transistor. So if you want, you can utilize 2N7002K, something like that. There are several MOSFETs that is available. So 2N7000 you can utilize, that is there. Okay, all right, so this was all about this particular like microcontroller schematic design. And if you have any doubt or any questions regarding this, or you want to like extend your concepts with others, then you can always write down your questions in the comment box and we shall be able to give you answers. Okay, so as you can see in this particular design document, what we have done is we have given you a complete picture of the each of the sections, like schematic design of like microcontroller section. Then we have the like temperature sensors or reset buttons, and like we have potentiometers. Then we have user LEDs. So as you can see, already we have done that user LEDs understanding. Then we have user push buttons and dip switches. So you can see user push button and dip switches are there. Okay, then we have USB micro B connection. If you want, you can have mini B also, not a problem. And USB normal USB 2.0 or 3.0 also you can connect. Then we have USB to UART bridge. So USB to UART bridge circuit is there, which is having UART to USB connections or USB interfaces. Then we have power supply interfaces with like input connector, or we have adapter jack. Then we have linear regulators for 3.3 volt. output and as well as 5 volt output, which is not being used in the circuit. Okay. Then we have, like the 5 volt connection process. So if you want it permanently, what you can do is you can utilize this IC, this resistor. So V bus will be permanently connected to the VCC, and you don't have to use any jumpers or anything, and it will be always powered up from your laptop. Okay. So that's all. This is what everything was there from my side. Thank you so much.